So now let's look at the Bertrand duopoly. So Bertrand duopoly is similar to the Carnot. You can think of Bertrand as individual firms setting the price given the other's price, as opposed to setting the quantity. So similarly, we have two firms that are selling identical products, and they must simultaneously choose what price to charge. So the firm that charges the lower price gains the entire market, but firms would rather charge higher prices. So there is a constant marginal cost of C for each firm, and there's no fixed cost. Okay, so we have players, the two firms, and strategy in this case is choosing which price to set. And notice that since price is continuous in this case, as opposed to discrete, we have a possible range of prices that goes from 0 to infinity. So the strategy set is from 0 to infinity for each firm I. So the payoffs are the same structure. Profit pi I equals total revenue minus total cost, but in this case, we want to set the Q as 1, which represent the total mass of consumers who are willing to buy the product. And the consumers are willing to pay the lowest price. So if price of firm 1 equals price of firm 2, consumers are indifferent between the two firms, and the market will be split 50-50. So let's look at the profit function. Now the profit function of firm 1 can have 3 different forms based on the relative price it sets. If firm 1 sets price lower than firm J, which is the first line, they get all the consumers, since consumers want to pay the lowest price possible. And so since profit function is Q times price minus marginal cost, and Q is 1, we can express the profit as just price minus marginal cost when price of I is lower than price of J. So how about the second case, when price of I is equal to price of J? I mentioned that the market is split half-half, so consumers are indifferent between the two firms, and so each firm would get 1/2 share of Q. So hence, we multiply 1/2 to price minus marginal cost. And the last case, when firm I charges a higher price than firm J, you can see this is the mirror case to the first scenario, but now firm 1 receives no customers, and firm J gets all the customers. So then the profit of firm I is 0. So we won't do a numerical example for the Bertrand duopoly because one can intuitively see what the Nash equilibrium is for the Bertrand. And the Nash equilibrium is for each firm to always set their prices to its marginal cost. Why is that? So let's look at the case where firm 1 charges a price smaller than its marginal cost. Then firm 1 is making a loss and would want to raise its price. So then it raises above marginal cost and below the other firm's price. However, in this case, we've seen in the previous slide that all the consumers go to firm I, and firm J is getting 0 profit. However, firm J would want to compete to get the consumers, so firm J would lower its price a little bit to match firm 1's price. And if these two firms keep competing to set lower prices until they can't go any further lower than their marginal cost, then that would be the Nash equilibrium, where each firm would have no incentive to deviate from setting their price to marginal cost. So note, I say in this slide that this is, intuitively speaking, the Nash equilibrium, because this is exactly not a mathematical, there's no actual mathematical proof that the profit function has a global maximum. We talked about earlier that in order for a function to have a global maximum, it has to be concave. But because this profit function is discontinuous, there can't be a global maximum. So this is called the Bertrand paradox due to the somewhat confusing equilibrium outcome. You don't see this in real life, where duopolies are setting their price equal to marginal cost. And it's probably because they're not really perfectly competing with each other, as in a perfect competition. So there you have it. We learned about the Cournot and Bertrand duopoly. I don't know which makes more sense to you guys, for firms to be setting quantity or to be setting price to compete with the other firm. I think in reality they do some of both, but this is a really good way to see how firms compete strategically with each other in a duopolistic firm. In the next several lectures, I'll talk about different applications of Nash equilibrium.